Good afternoon everyone, welcome to lecture number 9, and we talk about client-side development today. So last time it was Vaadin data model with all the key elements and how do we link data model to user components, how do we validate what the user has entered to the system, and how do we connect to an SQL database. This time we go a little on the client side. So far everything we've been doing was happening mostly on the server side. This time we move our focus a little to the browser. So this is Google Web Toolkit mostly. Of course it's all Java, so you don't have to worry about learning new languages or working directly with JavaScript. What we go through today is that we will try to make a simple Vaadin add-on. Step by step I will more or less explain how to do that. I will show you the results. So let's start. Client side thing is called a widget. So this is a representation of a component that runs on a server side. And the representation word here is crucial because the server side is not rendered to the user. So it's the widget that corresponds to a server side component that it's rendered. And of course we can use different widgets for the same component, for example. We start in Eclipse. Of course the Vaadin plugin to Eclipse provides a nice way to do that. So when we start a new project, then we can select Vaadin widget, and then we just provide a name, and we might want to change the package of the current application we are in. The plugin will create a bunch of files, and they are all located in the package we specify, and they are named according to our widget name. The most important file at the beginning of the development of a widget is our server-side component. All the logic related to the component is in that file. Since we are developing also a widget or a widget set for that component, there is a Google Web Toolkit XML file, a module file, that contains information what widget set will be used, describe the contents of that file later. What is important is that the widget set must be compiled to JavaScript in order to be used. This is except the Google Web Toolkit development mode I will talk about next time. So if we are using Google Web Toolkit development mode, we do not have to compile the widget set, but if we are not, then every time you make changes to the widget, then we have to recompile it to JavaScript so that the browser gets the latest version. And compilation takes a lot of time, so this is roughly measured times. So on my home computer, which has incredibly low amount of memory, it takes about 12 minutes to recompile the default widget set of Vaadin. Well, if you have a slightly better machine, then it takes 1.5 minutes, but it's still considerable time if you have to do it a couple of times per hour, for example. Once we compile the widget set, then compiled JavaScript stays until we change the widget again. And then of course the compilation takes all the resources that are available to your system. So expect 100% CPU usage and 100% memory usage, and basically you cannot do anything during that time. Okay, more created files, then they are moved in the client package. I think the current version of the plugin is somewhat buggy, as it should create a shared package as well. Those 3 files marked as they should be in a separate package, they actually should be in a separate package that is accessible to both client and server. But well, let's go through the files. So we have client RPC, which is an interface to allow the server to call the client. There is a counterpart server RPC, which allows the client to connect to the server. We have a widget, which is a Google Web Toolkit or any JavaScript or Vaadin widget. We have a state, which is a state of the component that gets serialized between the server and the browser. And then we have a connector which updates the widget based on the state changes. What we will do as a case example, and I think this is the best way to more or less show how this client-side development goes. So we will develop a small Vaadin add-on, or I will show you how it was done behind the scenes, more or less. So our goal is to have a grid representation of a data. So we have a container, and of course we can plug it to a table, which will render a nice tabular view, or we can plug it to a tree, which will show the same in the tree view, but we want to have a grid. So every cell in the grid represents the item, the whole item. And of course, that can be any component, so we provide a little customization to how do we want each cell to look. And then of course our aim is that it works with any container and allows you to click the items in the browser, so that we know that the user has clicked this particular item or another. So of course, since this is a very simple example, so we are going to ignore efficiency for a while. We are simplifying the code as much as possible, so we do not extend from field or select or any other server side. And we are going to ignore styling. I will just tell you how to do it, and if you want, then you can just download the sources and extend the component yourself. What are the design decisions and what is usually happening when you are developing a widget in Vaadin is that you have decoupled client from the server. So the server does not render anything and the client doesn't handle component logic. The server makes some changes and then the client just updates how the widget looks according to those changes. In this particular case, we want to have flexibility of having any component in the cell. So for example, one user might want to use the grid that just shows, well, labels with the IDs of the items. The other one might want to generate some images based on that, while somebody else might want to have a small table there with properties and their values. Of course, we want to have a meaningful default behavior, and this is something when you are developing Vaadin widgets. Well, basically when you are developing any component at all, you should have some meaningful default behavior. So out of the box, your component should work, and not that you have to set up something or otherwise the user will get a null pointer exception. So let's start with our shared state. So as I said, shared state is something that is, according to the name also, shared between the server-side component and the client-side widget, and it's used as a communication channel from the server to the client. And it's not the other way, so the client does not change the state to inform the server about something. There is another way to do that. It's the communication from the server to client. The state holds properties that both the client and server should know about, and they are of course determined by the functionality of our component. What happens behind the scenes is that the state gets serialized by Vaadin framework, so we don't have to do that. We just have to write changes to the state object. And what we can serialize is all primitive types, so integers, floats, doubles, booleans, etc. except the object, because there is apparently some problem with that. Of course, we can use strings, we can use beans, so any Java class with any other Java class that is serializable. And then we can use maps and arrays of the above mentioned. And in case we use maps or hash maps or hash tables or whatever's, they must be string indexed. And as I said, everything gets handled behind the scenes, so we don't have to explicitly do anything. And to optimize the performance, only the changes to the state are sent between the server and the client. And there is a concept of dirty components. I will explain that later. But in general, it means that the server-side component needs to send the changes to the state to the client. As I said, we can have basically anything in the shared state, and that includes components. Unfortunately, or fortunately perhaps, it cannot be done as we might expect it to be. So the client side works with widgets and the server side has components. These are two completely separate entities. So for example, as I said, the widget gets rendered in the browser, whereas the server side component is not, because it's just a representation of a logic of that widget, not the widget itself. So if we want to reference a component in the state, we have to use a connector. Fortunately, any server-side component implements that interface, so we can just do that. I will show you an example because we will be using that in our example here. Since we want to have components in the grid, then we have to be able to pass them from the server side to the client side. What else we need to do if we want to pass a component or reference a component in the shared state? We need to have that particular component in the hierarchy. So we need to either add the component or set its parent to something. And of course, this is all done on the server side. If we forget to do that, then we will get null pointer exceptions because the component is not present in the hierarchy. and then it's not possible to serialize it. Of course, this approach forces the server side to remember what components it created and manage them accordingly. This is more or less the cycle of how client and server side communication looks like. It always starts with the server side that changes the state. So something happened and the server side changes the state. Then behind the scenes we have the serialization of the state on the server side. That serialized string gets sent to the client side. The browser receives that. Then the client side part of the framework deserializes the object to something that the browser side can understand. Then the connector updates the widget based on what has just changed. Then we usually await user interaction. And then if something happens, then the RPC method, so remote procedure call, is done to the server from the client side. And then of course the server side usually changes its state according to what just happened, and the cycle goes on and on. Of course, there is a nice class for having your shared state, so it's called shared state. And it's a base class that you should use in all your projects. It is a class, not an interface, so you cannot implement shared state. You have to extend from it, which limits the number of other things you can include. So basically the state should just contain the variables and means to access them and nothing else. There shouldn't be any logic. It should be just a placeholder for information. And we do that by either getters and setters or public fields, and there has to be a default no argument constructor, because it has to be created on both sides. And of course meaningful default values, so there shouldn't be any nulls in the state unless you really want to have the null value, for example, there. But there is more, so there is abstract component state, which should be a base class for all components or component states. So if you develop a custom component, you should probably inherit from that instead of a shared state, because it stores and handles the common properties like caption, description, icon, height, width, and so on, and style names. The abstract component does precisely that, so it handles captions, descriptions, and the abstract component state, well, it's responsible for sharing this information with the client side. And of course every component has its own, or almost every component has its own shared state. So if you are extending a particular component, then you will likely extend from that particular component state rather than abstract state. So our grid state should probably store the number of columns we want to have in the grid. The number of rows is always of course automatic, because if we have 3 columns and 2 items, then we want to have 1 row, but if we have 4 items, then we want to have 2 rows. Of course we need to store the components we want to draw, and not directly but through this connector. We should store somehow the selected component, but it's enough if we store just an index of that, so that's okay. And what I decided to use for clarity is the public fields instead of setters and getters, so you hopefully can see some of the state on the right hand side. So there is a constructor that assigns primary style name, and then there is a field with number of columns. By default there are 3 columns. There is a list of connectors or the items that we want to render on the client side, and it's by default empty list. And selected item has index -1, so that means that there is no selected item. So this is basically what we do with our state. Okay, now the server side. As I said, this is similar to what we've been doing, or what I've been talking about on a dedicated lecture. If we are developing a widget that will be accessed on the client side as well, then there are some tricks or some things that you should consider as well on the server side. So first we have to be able to listen to client side calls. So the client side can use remote procedure calls to notify the server that, hey, something has happened with me and you should probably tell me what it was. Then the server needs to modify the shared state according to the logic. So if we select an item on the server side, then we probably want to determine the index of that item and then modify the state that, okay, the selected item is now this one. I said earlier that there are these dirty components. So in Vaadin 6 we used request repaint to force repainting the widget. Vaadin 7 introduces a concept of dirty component. So now we do not request repaint, we mark a component as dirty, and that means that the framework at the next possible opportunity will send the state information to the client. And of course the server-side component has nothing related to rendering. We want to have everything done on the client side, not on the server side. So what are the key methods of server-side component? This is pretty straightforward. So we have setters and getters for the properties, or some other methods that are related to behavior. So we do not have to explicitly, for example, we have these columns in the state. We do not have to have set columns and get columns method. We can have methods increase column count and decrease column count, for example. Then we should mark as dirty whenever we change the state or we did something that might have changed the state. And there is of course a shorthand method called mark as dirty recursive. So that means all the child components that we have, they also need to be synchronized. Then we have a method called getState, and it's recommended to override it so that we do not have to typecast the state constantly. So we just do it there. And then there is a method called beforeClientResponse, and this is a place in which you should write the contents to the state, the shared state, so that it ensure that everything that has changed will be synchronized. So our grid component will have a setter and getter for number of columns, the selected value. Of course, it will refer to the identifier of a selected item. Then there will be a component generator that we will provide default implementation for. And this component generator will be used to produce cells that will be rendered on the client side. And of course, we need to be able to set a container data source and read the container data source. And then, of course, we need to listen to all the container events that are happening. So, for example, when an item has been added, we, of course, want to have our grid to add a new cell there instead of just doing nothing. And then we mark our item grid as dirty when we set the value, or we change the selection when we change the number of columns and when anything in the container happens. As I said, this is not very effective approach because we will just recreate all cells, even though we, for example, just added a new one. But this is just a small example, not a production code. So in production code, you probably should fine-tune it to just send all the information that has changed and not all of the components.